Hello and welcome. I'm going to demo today how you can adopt a DataOps workflow for your data warehouse to speed up your time to insights. I'm going to be focusing on the transformation step in ETL. I'm going to demo this and show the typical lifecycle a developer can use to iterate very quickly over change. Here's a brief overview of our agenda. We're going to go over DataOps at a very high level. We're going to have an example look at what a pipeline would look like with the introduction of DataOps. We'll dive deeper into two of its key aspects, continuous integration and delivery. We'll then go through a demo of how this would work in real life. We'll go through the technologies used, and we'll be able to see how we automate our testing, data profiling, code quality reviews. So what is DataOps? DataOps reduces the time to innovate and experiment for data teams, thus increasing the velocity of delivering insights to our customers. This is only possible with automating the entire DataOps pipeline. Pipeline includes automated testing, provisioning of environments, creating documentation and updating it on every single commit, and profiling on every single change to understand how your data compares between your development and your production environments. For a more detailed overview of DataOps, please check out the link in the show notes below. Being able to demonstrate and measure our return on investment on DataOps via metrics will make this a much easier sell. Here are just a few examples of some of the metrics that you can use to start to measure how well your team are doing. And as you go on through your journey, you can see how these metrics improve. Metrics such as your mean time to resolve, i.e. how quick are you to resolving bugs or if there are system failures, looking at the frequency of your data deployments, as well as the ratio of your failures on deployments. Test coverage will also be a great indicator of the quality of the data that you have in your pipeline. Some of the steps we're going to take today to introduce DataOps will be removing a lot of the manual deployment aspects. We're going to be looking at how we can set up isolated environments on every single pull or merge request. We're going to look at deploying data models from source control. This is fundamental. Having your code versioned and have a history. Running automated tests on only the models that have changed. This is key. You may have a very large network of data models, and you only want to look at the ones which have changed and then their downstream impacts. We also look at improving code reviews with SQL linting, i.e. enforcing standards, best practices from the company on every single developer. We want to look at automated data profiling on every merge request. This allows us to check what we've developed in our development branch versus what we've got in production. So not only are we testing the code with code quality, such as linting, we're also checking the output of the data with data profiling. And finally, we want to deploy documentation and lineage updates on every single change. This is the thing which normally gets missed at the bottom, but it is exceptionally important and useful to understand how changes will impact future models. Here is an example of my DataOps pipeline. We've got our local development at the top left, and then we traverse these arrows to get to production. So there are several steps to this, but essentially what we're trying to do is make our local development very flexible, and then when we get to production, we want to have tested and profiled all of our data. So during the local development stage, we want to version control all of our code. So we develop in, say, a feature branch. I'm using the technology DBT, database transform, which I'll go to in more detail, but this is a technology that puts in a lot of best practices around software engineering for anyone who wants to transform data in a warehouse. And we'll be using this tool to populate our data warehouse, which in this demo will be Snowflake. And we'll be testing our code out in a development schema. Once we're happy that we can see that our changes are occurring in our dev schema, We'll also do a little bit of testing locally. Once we're happy with that data in our dev schema, we can then go on to the next phase, which is creating a pull request and having our continuous integration and delivery pipeline run through our various tests around profiling, linting, and so forth. We'll go into more detail on the next slide on this CI/CD step. Once it's completed the CI/CD process, we'll also have a new schema just for that pull request. And this allows us to share our work with our colleagues, maybe for our managers to review the impacts we have to our database. And then once they're happy, we can then merge into production. And again, we'll run through our continuous integration and delivery cycle again. I wanted to go through the continuous integration and deployment steps in more detail and what technologies we'll be using. It all starts off with version control. I'm using Git and managing my repositories with GitHub. Version control systems are the most important technology to master to collaborate with any type of coding project. If you're new to Git, check out the links below. Github Actions will be used to coordinate the pipeline by invoking CLI command line interface and software developer kits for each of these technologies in both our integration and deployment phases. Let's take a bit of a deeper look in the integration step. Linting your code is the first step. We want to make sure that our code meets our company's best practices. And we're going to be using a technology called SQL Fluff to do that. We'll be using DBT, database transform, to build out our schema for each pull request, but only the changes we've made. By only doing it to the changes we've made, we can skip out building out the entire data model and just focus on what we've changed. This will save time in terms of the build phase of our pull request schema, as well as cost in that our data warehouse, Snowflake, can be built by the minute. We'll then go through automated testing. We'll be using DBT and create expectations for this. And these tests will check to see if we've introduced any new bugs to our existing code base. Finally, we've got data profiling. We want to check to see how our changes in our pull request schema impact the production model. And with Datafold, we get an automated way of comparing our production to our pull request schemas. This will help us identify any anomalies in our data. That you can review the data profiling within the pull request. Moving on to the deployment phase. Once we've passed all our tests, we'd like to deploy our code, whether that be into the pull request schema or into the production schema. So the technologies which we're using and the steps we're going to be taking, we'll be using DBT to update just the models we have changed and update all of the docs and lineage related to those models. DBT allows you to define your schemas in YAML files, so you can write descriptions of columns, so you can update those when you make changes to your models, and it also keeps a track of the lineage. We'll be sending artifacts as well out of the continuous integration process into a repository, which we can then use for future CI/CD builds. This is where the magic happens. By storing DBT's state of what it knew of the lineage previously, we know which parts of the model changed on every single iteration. And that's how we know this change only impacts this subset of models. And thus we can, again, save that cost and time by only building those models that have changed. Now, DBT isn't an orchestration tool. That's where we use Airflow. Airflow, we won't go into this, but essentially in another video, I'd like to show how you can break down your DBT models into tasks within an Airflow DAG. And Snowflake is our data warehouse, which is brilliant to save money. They've got a great free trial. You can be billed for just a minute if you just run your workflow for that long. Okay, enough talk. Let's see this in action. First, let's quickly go over the fictitious company that we're going to be using in our demo. Snowflake provides a benchmark dataset called TPC-H, and it comes in various sizes from 1 to 1,000. And this allows you just to scale out a demo database to understand its impact and cost. Over on the right, we can see what the base model looks like. And with this normalized model, we'll be using DBT to create various facts and dimensions. The aim of this demo is not to show the best practices on data modeling. It is to show how we can increase the velocity at which we deliver via DataOps. We're going to be using the TPC-H10 variant, where the actual rows are multiplied by 10. So this line item table, for instance, will be 60 million rows. And we're going to be using the smallest Snowflake instance for this, an XS small, which only costs $2 every hour. And as all of our testing will take less than an hour, we'll only be paying a fraction of that on every single run. And with Snowflake, your compute is completely separated from storage. The compute cost is by far the more expensive part, and thus, and with Snowflake's ability to automatically shut down after a query, we're only paying for the time in which we're doing our transformations as part of our DataOps workflow. The size of this database is around 7 to 8 gigs. Let's pretend that I'm a junior developer. I don't really know what I'm doing. I'm going to go into all your SQL models and I'm going to make a load of changes. And then we're going to catch all of those problems during our review process. We're going to forget it's all about even doing any local testing, any local profiling or checking in the code. We're just going to push our code and see what happens. And what we'll find is that our continuous integration solution will pick up these problems and flag during the review cycle not to go any further. Let's see that in action. In our company's repository, I'm going to go and change some of our data models. I'm going to first of all navigate to a particular model. I'm going to go into our fact orders table. I'm going to mess up some of our company standards for naming. Let's just change this up to uppercase, and let's just add some. We could also pick this up locally when we're testing via SQL Fluff. And when we run the command, we would see that inconsistent capitalization of keywords and unnecessary trading white space. We're not going to even do that. We're going to skip that as a junior developer and just try and push this as quickly as possible into the pull request. Let's also remove some of the data that we're going to have in our pull request schema. So I know that this table has around 15 million rows. Let's just limit it to half of that. So let's just limit it to 7.5 million. And I'm just going to change this column, net item sales, and add in a new column as well. So I've just added in some extra logic that will sometimes make this column turn to null when there is a high priority order. And I know that we currently have a test that ensures that this column is not null. So we'll see that break in our automated testing. All right, let's create a branch. Let's commit those changes that we made. And let's push these changes to our repository. From GitHub, we can see a new branch is created. Let's go and create a pull request to start our CI pipeline off. And let's create that pull request. Brilliant. You see that there have been 3 workflows that have been triggered on that pull request creation. The first one is going to perform our linting with SQL Fluff. The second one is going to test our deployment. It will also push our code into the warehouse in a pull request schema. And once that completes, Datafold will do data profiling on that pull request schema. So I'm just going to wind forward a couple of minutes. We now can see that a couple of our tests have failed. Both our linting has failed and our testing for creating our pull request schema has failed. Let's first of all jump into our linting step. In our SQL lint models workflow, we can see that the step to lint our DBT models has failed. And we can see which line numbers and which positions those errors have occurred. We can see the original two linting errors we had with inconsistent capitalization and unnecessary trailing white space. We also introduced a third error, and it looks to be due to the fact that we have calculations and aggregates before simple select targets. So we'll also fix that bit up. Let's also check out why our test and deploy step failed. And in our deploy phase, we can see a load of tests have been run. So these could be tests written by other developers. And one particular test for the net item sales amount in our fact orders, so this was the column that we changed, has an error. And it is a not null error. So we'll have to fix that up before we want to deploy. So let's fix up our null error. Let's just put this column to be 0 when we have a high priority order. And we'll also change this back to our company's best practice, lowercase, for our select statements. Let's commit and push again. Let's return to our pull request, and you'll see that those same continuous integration pipelines have been kicked off again. As you can see, this is an iterative feedback loop we get from having continuous integration. Okay, some time has passed, and it looks like this time we've passed all of our linting rules that our company has set up. We've also passed all of our tests and deployed to the production schema. And we're currently waiting for Datafold to send us a data profiling report on our changes between our pull request and our production data warehouse. Let's just have a quick look at that test and deploy production schema cycle again. We're just going to look in a bit more detail whilst we wait for the Datafold data profiling. So this is a Github Action. We're setting up the job, we're checking out the source control, we're installing some dependencies such as Python and DBT. We're also getting some credentials from AWS, so I've got some secrets stored in AWS rather than in a plain text file in my code repository. We've then got steps to get state of our prior DBT runs. So let's look at that deploy stage in further detail. We're only deploying one model, one table into our pull request schema. And that's because we've selected a table and changed table which has no downstream impact. But our next demo will go and impact a model that has many downstream impacts, and we'll show you that only the changed models are being built. And if you were to look into this table, it's being built off of the production database. So we don't have to clone or duplicate data anywhere. It can stay in place, and we know based on the lineage what should it depend on. Before, we ran tests on that table, so that fact orders table, but we had an error on one of our not null conditions. Whereas now you can see all of the tests are passing. We've got tests for not null on a particular column, as well as uniqueness tests on a particular key. And DBT lets you also create custom tests. Finally, some of the last steps are to let Datafold know what pull request schema to validate against production. Let's have a look back on our pull request. We can now see that Datafold has produced a data lineage. We can now see that Datafold has done some data profiling in our pull request. Let's just open this up to go into even more detail within the Datafold UI. So I'm getting some indication here that there's been some changes to the primary keys and to some values. Let's take a look at more detail what that is. We've also got a new column, which has been highlighted here. In our primary keys, we can see around about a third of our rows seem to be missing. And some of our values look to be very off. We can drill down into this further. Let's just quickly look at the schema. We can see that new column that we added in. If we look into the primary keys, we can show the primary keys that are in our A dataset versus our B dataset. Dataset A is our production table, fact orders, and dataset B is our pull request where we've altered fact orders. And we're getting back the difference where there are columns in A but not B. So this is really useful for debugging and understanding what may have happened. We also get profiling. Now let's look at some of our profiles. We can see lots of data seems to be missing from any time in the future after 1995. And that's probably due to the limit clause that we added in. Go down to that net sales amount. Yes, net sales amount. We can see in dataset B, our pull request, we seem to have a lot more with zero value. And this will highlight to the reviewer something has gone very wrong. We can also review on a line by line basis. So for each key, we get to see the columns that have changed. So this is a column that we changed, net items, sales amount. And for instance, we can see for this order key, we have changed it to 0, as expected, but not what we intended our junior developer to do. We can give the feedback to our junior developer that they need to update and remove that limit clause. There's also a couple of other columns here to the right, and these are going to change because they are in relation to what batch ID and what the timestamp of the batch was. So these are expected to change. Just to recap, our junior developer has done some development. They've not even pushed their changes into the development schema. They've gone straight into a pull request, and we have caught linting errors. We've caught issues where we've seen rows have been deleted in our data profiling, and we've also seen that tests have been failing. Let's just have a quick look at what that pull request schema looks like in Snowflake. So I'm in my Snowflake UI, and I've just gone into my database, which holds all of my tests for each pull request. I'm going to refresh that, and I can see my last 2 commits, the one which had the issues and the one which we fixed the problems around linting. They're here now. Let's just have a look at that fact orders table. We can see some of those rows which have 0 in because of their priority status being high. So our changes have been reflected in our pull request schema. So even though our tests are passing, we did see during the data profiling process, there are a lot of values that are missing still. However, I want to show you an end-to-end cycle. So I'm going to merge this pull request into our main branch. So we've now gotten to the stage where we've just merged into production. And again, we're going to kick off that CI/CD process to test and deploy. And some of the extra steps in our deploy process, when we're promoting to production, we'll be building out some artifacts in relation to lineage and documentation. Now that this branch has been merged, you'll see that I have a second action that kicks off when a branch has been deployed into production, in this case, my main branch. So again, it's a Github Action, and it will perform the same validation as when creating the pull request schemas, but it also has some extra steps to publish docs and generate documentation, as well as the lineage. And I just wanted to demo that. The only change that we'll be able to see is that new column that we've added in. So let's take a look for that. So we've got under our models, we've got our warehouse, and we made a change to our fact orders. So you'll notice that new column will hopefully be in here somewhere. Here we go. And if we had written a description in the YAML file which configures descriptions for each column, we would also see that pop up here, as well as documentation on the columns and tables in your warehouse. We can also look at the lineage. Let's go back up to our project and click the lineage graph. You'll get to see the model that's been configured as part of the DBT framework. The only change we made was to this fact orders. And as we've said before, there are no downstream impacts. Let's pick a model which has more downstream impacts, such as the suppliers. As you can see, this will impact several other models. These will all need to be built in our pull request schema and tested and profiled to see the impacts. So let's check out for our second demo, making a change to our suppliers table. Let's make a change to our suppliers table. And push our change and then create a pull request. And again, go back to our repository and let's create that pull request. Again, those same workflows have been kicked off. However, this time, they're going to be working on a much larger data model because they're going to be checking against all of those downstream models, not just the one table like in the fact orders example. This time around, now that we've made that change to our suppliers table, we've had to build a lot more models. So I've just gone into our pull request build. In the deploy step, unlike our previous demo, where we only saw a change to one model, we can see that several other tables have been created in our pull request schema. And again, tests will run for all of those. So here I've got tests for our order items, as well as our tests that we defined for our orders table as well. Let's just have a quick look at those tables in Snowflake. Let's hit refresh again. Okay, here's our latest schema. And as you can see, unlike fact orders, all of these tables have been built because they were downstream dependencies of the supplier table. Let's recap what we did. We went over two examples. The first was changing the fact orders table, where we saw all of our continuous integration components kicking in. Second, we updated a model with several dependencies and showed how using Slim CI with DBT, we were able to just build out the models that have changed in our pull request schema. In relation to performance, for our continuous integration and delivery builds, again, the warehouse we were using was an XS small at $2 per hour. When scaling up this data source from TC10 to TC100 on the small XS small warehouse, the amount of processing time to produce our pull request schema changed from 4 minutes to 80 minutes. Now, I don't know about you, but I don't believe any developer is going to want to wait 80 minutes for all of these tests and pull request schemas to be generated. But there are several strategies to really drive down that time when you're working with much larger data warehouses. The first thing you can do is increase compute. Tested building this out on a large data warehouse from Snowflake, cost of $16 an hour, and it completed within around 4 minutes or so. That solved my problem, but for larger data warehouses, there are even better strategies. Build times can be dramatically reduced when scaling work to run concurrently. DBT is not a scheduler, but it can run transformations sequentially. So for the purposes of this demo, we've just been using the DBT sequential runner. Using DBT's Ginger templating, we can dynamically filter based on the environment that you're using. So if you're in development or in test, you can actually restrict the amount of data that's flowing through the entire pipeline. I've got a quick example at the top right here, where this macro will get inserted into a table, and based on the column name, such as a date column, we can restrict it to an n number of days based on a particular environment. So we can say, only bring back the last couple of months worth of orders, rather than the entire history. And again, this will reduce massively the time to iterate. Let's go through some of the main technologies we used. I've got links in the show notes for further reading. Let me explain why I chose each of these technologies for this DataOps pipeline. DBT is a tool which lowers the barrier to entry for analysts and developers to start contributing to your project and applying software best practices under the hood, such as being able to write automated tests exceptionally easily, keeping track of all of their documentation and lineage changes, with a consistent way of creating your models, you're able to understand each other's code and make fewer mistakes along the way. Automated tests are configured or written in the same location as your data models. No longer do you have to go to a different repository where you're writing all of your tests. DBT will automatically generate your docs and your lineage. This is crucial for impact analysis when you're trying to understand if a change will have an impact on particular models. And using DBT's slim CI best practices, we can identify only the models that have changed. For data profiling, we use the technology Datafold. With version control, we are able to see the historical changes that we've made in our code. We also need to do regression testing on how our code impacts our data warehouse. This is where Datafold comes in. It'll allow us to automatically generate and data profile our code between our commits and our target. For instance, here we've been using in our DataOps pipeline the merge request and comparing that to production, so we can get deltas in the data. Datafold data diffing allows us to detect any differences in our tables, such as columns that have changed in name. We can also see primary keys that are not null, or any duplicates that have been introduced. We get to see column data profiling to understand the skew of our data, and we can also see how our data sets change over time. On to two other technologies, GitHub Actions and SQL Fluff. So just very quickly, GitHub Actions we've been using to orchestrate our continuous integration and delivery pipelines. But you could have also just used another tool such as Circle CI, GitLab CI, Jenkins, etc. And with SQL Fluff, we're able to use this tool to lint and check that our code conforms to our company's best practices. This will make sure that your developers are all writing in a consistent manner, and it makes it a lot easier to read your code throughout your code base. Thank you for watching this demo on how to implement DataOps.